Morning, dear students. Let us talk about plane strain condition and derive the elasticity matrix, or other way called as D matrix. First, let us know what is plane strain condition. I can straight away cite an example here, like long bodies. Okay, like for example, dams. Okay, like pipes. Okay, so etc. come under this category, plane strain. So theoretically, how do you define the plane strain condition? Say if the strain is zero perpendicular to the plane of the body. Okay, the strain is zero perpendicular to the plane of the body. So such condition we call it as plane strain condition. Okay, so how do you derive the stress strain relation for this plane strain condition, and how do you formulate this elasticity matrix? Okay, let us say consider the strain in x direction. Okay, that is sigma x by e nu sigma y by e nu sigma z by e. Okay, epsilon y, that is strain in y direction, y by e, x by e, z by e. Okay, strain in z direction, z by e, x by e, y by e. Okay, so because of stresses in three directions, x, y, z, we have these strains in x and y, z directions. Okay, so let the condition is plane strain condition. Okay, let the plane strain is applied. Okay, because this is three-dimensional, so now you apply plane strain condition. So say the body is in xy plane. Okay, then strain in the perpendicular direction is zero. So let us say epsilon z is zero. Okay, so substitute this condition into this. So I consider the third equation. So that means left hand side will be zero. Then sigma z by e minus nu sigma x by e minus nu sigma y by e. E is common and will be sent to the left hand side. So 0 into E is 0. Then sigma z is equal to nu is common here. So I'll have sigma x plus sigma y. Okay. So from this, I am able to write sigma z is equal to nu into sigma x plus sigma y. Okay. So now consider this as, let us say, 1. Now write epsilon x is equal to the strain in x direction mu into sigma y by e minus, in place of sigma z, I'll write this. Okay, so there is already nu, so it will be nu square sigma x plus sigma y. Okay, so this is epsilon x. Then in place of epsilon y, sigma y by e, x by e minus nu by e into sigma z, I'm going to replace here like x plus y. Okay, so this is what the first two expressions are going to become, like epsilon x, where I have replaced the sigma z here, epsilon y, I have replaced sigma z. Okay, so let us simplify further. So I'll take E common and to the left hand side. So it will be E epsilon x is equal to sigma x minus nu sigma y minus nu square sigma x minus nu square sigma y. Same thing with the second equation. Sigma y minus nu sigma x minus nu square sigma x minus nu square sigma y. Okay, so just expanding this nu square into this nu square into sigma y. Okay, yeah. Further simplifying the first equation, it is E into epsilon x is equal to sigma x. See, you have two terms with sigma x here. Okay, so 1 minus nu square. Okay, say minus nu is common here. Sigma y is common. Okay, so what you are remaining with is nu sigma y has taken common. So it is 1 plus nu is left over. Same way, second equation, I'll take sigma y. There are two terms with sigma y here and here. So 1 minus nu square and minus nu sigma x common, and I'll have 1 plus nu. Okay, and now you see here it is like I have 1 minus nu square. It's like a square minus b square. So that can be written as a plus b into a minus b. So E epsilon x sigma x 1 minus nu 1 plus nu. This I'm expanding like this. Sigma y, it is already there. Same way y also 1 minus nu and 1 plus nu. Sigma x 1 plus nu. Okay, now you see you can take 1 plus nu common from the right hand side and send it to the left hand side. So it is E divided by 1 plus nu into epsilon x is equal to sigma x into 1 minus nu remaining minus nu sigma y is remaining. Second equation with epsilon y, sigma y 1 minus nu is left over and minus nu sigma x is left over. Yeah, now from these two equations I need to eliminate, say let us say sigma y I want to eliminate. Okay, eliminate sigma y. So let us say this is equation number 2, this is equation number 3. Okay, see if I want to eliminate sigma y, the equation number 2, you have got a nu multiplied by sigma y. Whereas here sigma y is 1 minus nu multiplied. Okay, the multiplier is 1 minus nu. So what shall I do? So multiply equation 2 with 1 minus nu, and equation 3 with nu. So that will make these two terms same. Okay, so I am going to multiply equation 2 entirely with 1 minus nu. Let us perform that. So E into 1 minus nu into epsilon x divided by 1 plus nu is equal to sigma x into 1 minus nu is already there, and you are multiplying again with 1 minus nu. It is whole square minus nu into 1 minus nu sigma y. That is the modified equation 2. Second one, equation 3, I shall multiply with nu. Okay. So E into nu into epsilon y divided by 1 plus nu sigma y into 1 minus nu is already there. So we'll multiply with nu minus nu is already there here. So again you are multiplying with the nu. So it becomes square sigma x. Okay. Yeah. Now you add these two equations. Okay. Right. To eliminate sigma y, we are trying to eliminate sigma y. Okay. So from the first equation, this is sigma y term with negative sign. Second equation with the plus sign. You see, both are same. So I'll just cancel out these two and I add here. So you find this common term here. E by 1 plus nu is common. Okay. So what is remaining here is 1 minus nu into epsilon x plus nu into epsilon y is common from this, which is equal to right hand side you see sigma x common 1 minus nu whole square minus nu square. Okay, so this if you expand like a minus b whole square, a square plus b square minus 2ab minus nu square is already there. So this plus nu square minus nu square goes. So what you have here is 1 minus 2 nu. So now I have got sigma x value is equal to E by 1 plus nu. This comes to the left hand side and it goes to denominator 1 minus 2 nu into 1 minus nu into epsilon x plus nu into epsilon y. Okay. So this is the expression for sigma x. Okay. Now similarly, if you try to eliminate sigma x, you'll get sigma y expression. So I'll write it directly like 1 plus nu 1 minus 2 nu into epsilon x plus 1 minus nu into epsilon y we get. So if you do the same similar procedure, you will find this expression for sigma y. Okay, yeah, we have one more stress term to be evaluated, that is shear. So that can be done directly. So we have the shear stress by shear strain is equal to G. Okay, shear modulus. And from the relation between Young's modulus and shear modulus, okay, I can write, okay, so E is equal to 2G into 1 plus nu. This is our relation between the two moduli. Okay, so where I want G here, so E by 2 into 1 plus nu. So now I want shear stress, which is equal to E by 2 into 1 plus nu into gamma xy. So these are stress strain relations for these three, or the stress strain relations for plane strain condition. Okay. Now let us write them in matrix form so that we get a D matrix. So for D matrix, okay, you need to write them in matrix form. So left hand side I have sigma x, sigma y, tau xy, because we are trying to go with the xy plane. So the common term you see, it is e by 1 plus nu into 1 minus 2 nu is the common term for these two expressions, but not with the tau xy. Okay, so first let us write that common term e by 1 plus nu 1 minus 2 nu. Okay, then the matrix, then the strains epsilon x, epsilon y, gamma xy. Okay, yeah, so first equation is sigma x is equal to e by 1 plus nu 1 minus 2 nu into 1 minus nu epsilon x, 1 minus nu into epsilon x plus nu into epsilon y. So they are the two elements in this matrix. 1 minus nu, nu. Shear is not there in the first equation. Second equation, if you observe, okay, the e by 1 plus nu 1 minus 2 nu common, nu into epsilon x 1 minus nu epsilon y. Okay, so if you try write that, nu 1 minus nu, shear term is 0. Now the shear stress to write in this matrix form, you need this common term where the denominator 1 minus 2 nu is absent. So I'll introduce that, like 2 into, so 1 minus 2 nu is not there, I'll introduce it. So I have to introduce the numerator also, so gamma xy. So now the common term goes like this. So this one, and no normal strain components, 0 into epsilon x, 0 into epsilon y. What is remaining is 1 minus 2 nu by 2. 1 minus 2 nu by 2. Okay, into gamma xy. So this is the matrix form to be evaluated for the plane strain problem. And this relation we call it as matrix elasticity matrix or constitutive relation for plane strain condition. Okay, thank you. We'll be back with the next session.